Sway in the wind. Okay, so today we're moving on to one of those concepts that I think if you're here today, you're going to think it's pretty manageable, but if you're not, it's pretty complex. So we are now going to be doing equations with multiple angles. Now, with multiple, this means multiple angles. We're actually not doing sine x equals anymore or cos x equals. We're doing cos 3x, sine 3x, sine 5x, okay? Now, it's important to understand what is going on when we do this. It can't be just magic, here's formula, do it, okay? I know we love that, right? But it doesn't help us in the diploma, because the diploma, there's a lot of questions that get away from just know the formula, but do you know what you're doing? So I would like you to see the difference between cos x equals negative root 3 over 2 and cos 2x equals negative root 3 over 2, because they are very similar but different in just one way. Now, how does that affect things? Now, if you do cos x equals root 3 over 2, well, let's do cos x first. Now, here would be 1, and this would be like negative 1. I'm a bit too far down. Okay, and, right, we know that cos x starts high, actually goes through 90, 180, it's down to negative 1, okay, and then 210, 240, 270, it's up here, and then, so this is what a cos graph looks like. So that's cos x. Now, if you go and do negative root 3 over 2 down here, okay, it will go through at, I'm going to do this in red, here and here. Now, these answers should coincide with, where does cos x equal root 3 over 2? Negative root 3 over 2. And here, right? So where? 5 pi over 6 and, now, I don't know about you, but I know a lot of the last class. Are you at the point now that radians are easier than degrees? Okay? And so we're getting people that are good at their unit circle will find that's going to happen. If you're still not good at your unit circle, degrees still. So I would graph it using that, but then think about it. How many degrees is this? 150, right? Because that's 30, or pi over 6. And this one would be 180 plus 2 plus 50 is 210 degrees, okay? So you could see that we got x to equal 150 and 210 degrees here. Now, why don't we graph cos 2x equals negative? So if you do cos 2x, and you put that into your calculator, you're going to get something that looks like this here for the first period. We're going to come through here and here, so it looks like this. Okay, and then that's going to repeat again, go through there, be down here, come through there, so then it's going to come okay, and then we've got negative root 3 over 2 there. Now, first of all, how many answers do you get? So there's 4 answers. Anyone know what the first answer would be? Even by looking at the graph, what do you think the first answer would be? Any educated guesses? Well, we got to stay in degrees. What do you think the other one is? No. Start looking at the 2 graphs. Start looking at the answers. Start seeing if you can come up with some sort of 105. Because if you could go back to the first unit, what happened? From here to here, what happened? Horizontal stretch by? Now, does this mean horizontal stretch by half? X getting replaced with 2x? Does that mean that? Yes, it's always meant that, so it's good. That's staying consistent. What has happened to both of these answers? They got horizontally stretched by a half. The question is, what would these 2 be? Yes? How about the next one? 285. Okay, so some of you guys are starting to come up with something. Let us in. How did you get those? Okay, so you got this angle. What'd you do to get 255? So you added 180, right? Now remember yesterday I was telling you that, running on the treadmill, and we're trying to pass time, so we're looking at pictures. When you're just looking at a picture, you won't do very well. But if you're looking at a picture and you're making generalizations, you're making up rules, you do remember it. If I just looked at it, and I gave it to you, and it's like, how many people are smoking a cigarette? Now you're really trying to, but if you would actually said, okay, 3 people are smoking a cigarette, this is the house number. If you've consciously said those things and put them in there, you're not really using the picture anymore. You use the picture to make the rules, and you're using the rules now. So, how are we even coming up with this number? Like, it can't be just random. Maybe it was. Sorry? How do you know? Yeah, that is the period. What if you didn't have this picture? How do you know that the period's 180? Yeah, because if you remember from way, way, way back, period equals 2 pi over b. What is b? So b equals 2 here, right? So p equals 2 pi over 2, which equals pi. Or I should be saying 360 because we're in degrees here. Okay, now with all of this stuff here, we're going to do another question, and I want to see if you have established any rules. Because if you've got rules, you can do any question I give you now. So I'm going to do a nice extreme. I'm going to do it on the side of your book here. Hopefully you've got enough room. So if A, I told you cos x equals negative root 3 over 2. If I told you that. And B, cos 5x equals negative root 3 over 2. I want to give me all the solutions to B. We'll stick at degrees. So this is between 0 and 360. Now, the first question I want to ask is how many solutions would A have? Now the big question. How many solutions would B have? Very good. So now have you established a rule to do these? How did you go from here to here? What rule did you guys do? Because 10 is right. How could you do this if I gave you cos 1/2 x or cos 3x? Could you get the number of solutions? Yeah? So we took two solutions from A and we multiply by 5, which is, what is 5? B, or B value, right? So you really can take the solutions from A and multiply by B. Now, we already know that the solutions were 150 and 210 for that one. What would be my first two solutions for cos 5x? Very good. Hey, Graham, you got to let us in on how you got that, though. Nope. I don't want you doing that. Because it's not multiplied by 1/5. Why? Why do you multiply? No, you think that's the same, but it's not. Okay? Because what do we always do? What is that? What is 5x? It's a horizontal stretch by 1/5. So if it's 1/5, why would we be dividing by 5, right? So we need to do, because this is a horizontal stretch by 1/5, so make sure you multiply by 1/5. Okay, almost done. How do I find the next value? I got 10 to find. How do I find the next value? How would you get 102? What do you have to do, you guys? Why would you add 72? Okay, your period is 360 divided by 5, which equals 72 degrees. So you got to add 72 here. So your next value should be 102. I get you. I think we were thinking of two different things because I'm like, what do I need to add? And you told me the answer. Okay, so I got to add 72 to 42. Remember, I've got to take those two, like they're separate. So what's going to happen is you're going to get this. It's going to be kind of like you're going to leapfrog those ones, right? And then this one here goes to here, here, and here when you're trying to find every second one. So then my next one should be 114. Is that what it is? And then we can keep going and keep going to get the rest, right? Now, what? Yep. We're gonna. So you see this one here, 30 plus 72. So I skip a blank here, and then 42 comes over to become this one. I don't want to take 72 to this and get the one beside it. Exactly. Which is? Yeah, so that'd be 174 because I'm going to take 72 to that one. Now, what would be the general solution? The general solution for cos 5x equals negative root 3 over 2. Okay, in other words, how would I keep going here and here and here and here? Because this is 10, but I want to go to infinity both ways. Yep. 30 degrees plus 72n, and 42 degrees plus 72n, n is in the integers. Because that's how I'm getting all those ones, right? Those 10. So if I need to go to infinity both ways. So what I'm trying to get you to do is like come up with some rules to be able to do these. Okay? So we've basically have done 2 pages of notes in that example. So I want to go right to this page here, and we're going to solve sine 2x equals negative a half. So I'm going to do steps now. So step 1 is, do we know how to solve for sine 2x equals negative a half? Or what do we know how to solve, how to find? What do we know how to find on our unit circle? We know how to find sine x, right? So we solve for sine x equals negative a half. Why? Because we have the unit circle. See, we have to use what we know, and then we'll use another rule after that, okay? So, when does sine x equal negative a half? Come on, you guys have the world record for unit circle. You should be able to do this. 7 pi over 6 and 11 pi over 6. So the answers are 7 pi over 6 and 11 pi over 6. Now step 2. We want to know what would be the number of solutions for sine 2x. 4, right? 1, 2, 3, 4. So it's kind of an A, B. A, we're going to find the number. And why do we have more? Because we're doing a horizontal stretch by half. So I want you to picture your screen had that big one. When I do a half, I'm squishing. You know, more is going to get on there. Okay? So it's basically because we're squishing it in, the, right? And don't forget what we know. It's a horizontal stretch by 1/2. So it squishes, right? You're going to get more on that screen on the period between 0 and 2 pi. Now, the question would be, how do I find the first one? Since it's a horizontal stretch by 1/2, what would be the first one? What do I do to 7 pi over 6 to get the first one? Multiply by 1/2. So that would be 7 pi over 12. And this we're going to multiply by 1/2. Why? Because it's a horizontal stretch by 1/2. So that's going to be 11 pi over 12. Okay, now step 3 is find other solutions. How do I find those other solutions? No, we don't multiply it, do we? We're going to add what? A period. How do we find the period? What's the formula? P equals 2 pi over B. So in this case, P would equal 2 pi over so that's pi. Now, so we're going to come up here and we're going to add pi. Now instead of pi, because we need a common denominator, what is pi to be able to add that nicely? 12 pi over 12, right? That's 12 pi over 12. So we take the first one, add 12 pi over 12, so we get 19 pi over 12. Take the second one, add 12 pi over 12. And you will get 23 pi over 12. I'll do that in blue here. Okay. What would the general equation be for sine 2x equals negative 1/2? Well, you guys, what would be the general equation? Look at the last example that I did. What are we looking at? Seven pi over 12. What did you say? Yeah, plus pi n. See how that's getting me the 19 pi, and if I had to keep going, and then I'd have to do 11 pi over 12 plus pi n. That is in the integers. Okay, and that's it. Now, we're going to do one word question, but I want you up here put a big asterisk. For tan x, make sure you're doing pi over b for period, and it's different whenever you find them. Once you have the first one, you just add period, add period. So you don't go every second one for tan. Okay, now let's do a one word problem so you can see how these kind of work. And you'll be very impressed to see that my Ferris wheel is full color. Okay, now here is the equation for this Ferris wheel. Okay, Nancy, we got to be paying attention here. Okay? Because the rest of us need to know this, right? I know you do already, but we need to know it. Now, determine the time it takes the Ferris wheel to make one complete rotation. What is another way of saying one complete rotation? Period. How are we supposed to find the period of this Ferris wheel? 2 pi over 12. So this is the same thing as 2 pi times 12 over pi. So that equals 24 seconds. This thing goes around one time in 24 seconds. It's an awesome Ferris wheel. Okay. Now, algebraically determine the times during the first minute of the ride when the student is 7 meters above the ground. Okay? So in other words, we're looking for t. Now, we're going to put a 7 equals cos, or negative 4 cos, I should say. Let's see this. Negative 4 cos pi over 12 t plus 5. Now this thing looks kind of impossible to solve, but you'll see actually it works out quite nice. Now, this formula will give me, now I don't know if you realize it, but there's going to be twice that you're 7 meters above the ground. Once when you're going up, once when you're going down. So this is in the period of 24 seconds, right? Because it's only going to give us the 2. I'm going to be able to find the rest by doing what? Because why do I have to find more? Because it says in the first minute of the ride, how many times are you 7 meters above the ground? So this isn't going to cut it if I just put 2 answers down. Now, we've got to do some math here to find out cos. Now what would I do next mathematically here? Yeah, minus 5 to both sides. So you will get 2 equals negative 4 cos pi over 12 t. Should I do next? Divide by negative 4. Negative 1/2 equals cos pi over 12 t. Now right now you're going, yeah, so what do I do now? What do you know? What have I made you know for the last 2 classes? Unit circle. So do I know when cos theta equals negative 1/2? That occurs when? You see how much you need your unit circle? And believe me, if you think the game is pressure, you got to think about when it's worth 50% of your mark. To me, that's pressure. Playing a game in class, that's not real pressure. That's like, what's the worst going to happen, right? But on a test, if you don't know your unit circle, like if you freeze on your unit circle, so where am I? Yeah, and 2 pi over 3 and 4 pi over 3. Now the question would be, where would cos pi over 12, what would those first two answers be? Okay, my question to you is, how do I find those? What do I need to do? What do I need to multiply by? Okay, can I come back here? Did we multiply by the b value? Did we multiply by the p value to get from here, b value to get from here to here? No. We multiplied by 1 over 5, didn't we? So what are we going to multiply by here? Oops. What am I going to multiply by here? Can anybody tell me in words what's going on here? From here to here, what's going on? When we go from t, we got t or x getting replaced with pi over 12 t. What is that, you guys? It's a horizontal stretch by 12 over pi. Remember, the diploma's soon, right? So we're going to know our trig well, but we got to know our transformation unit well, too. So let's multiply by 12 over pi, and what do you get? Pi's cancel, and you get 24 over 3, which is 8. 8 seconds. At 8 seconds, and this one be what? 16. So, therefore, the answer to this is 8 and 16. Now, why am I not done? Because it says how many times in 60 seconds. So these were my originals. I got to come up with some more. I don't know how many more, but I got to come up with more. Because it's 8, it's 16. Then it's coming again, and again, and again, and again, right? How many times, or at what times, will it be happening? What do I need to do to get this one? Add what? Add what to what? Well, what's my period? 24 seconds. What do I add it to? 8. So I'm going to go plus 24, and I will get 32. There's more time on the clock. Yes? In 60 seconds? Yeah. Because it's 1 minute asked for it. In 1 minute, okay? Guys, we just got to finish this up. What's the next one? Okay, is there more? What's the next one? Okay, I got someone saying 60. So How do you get 60? 56 is the next one, because if you take 32 and add 24, what's the next one? 64, too big. So this is your answer right here. 8 seconds, 16 seconds, 32 seconds, 40 seconds, and 56 seconds. So doing 1 to 6, 8, and 10 to 12.